Today, I can use long division to divide polynomials by other polynomials. I can use synthetic division to divide polynomials by binomials of the form x plus k or x minus k, and I can use the remainder theorem. So as the warm-up, let's go ahead and just review the process of long division, and then we're going to get into synthetic division here in a little bit. So remember, for long division steps, it's divide, multiply, and subtract. Bring it on down and bring it on back. Divide, multiply, subtract, bring it on down and bring it on back. Okay, so I'm going to go ahead and write my dividend underneath this long division bar. Remember, if there's any term that we're missing, we need to put a zero placeholder in. So I see x to the fourth. I'm missing x cubed, so I'd have to put 0x cubed. 2x squared. Then I have x to the first, right, minus x, and then a constant. So it looks like the only term we need to put in is the 0x cubed. So I'm going to have x to the fourth plus 0x cubed plus 2x squared minus x plus 5. And then our divisor is x squared minus x plus 1. Okay, and I'm just going to zoom in a little bit here so we have this a little bit closer. We have divide, multiply, and subtract. So the first step is divide. I'm going to divide the first under the bar by the first outside. So I'm going to have x to the fourth divided by x squared, right? Don't be a hero. Don't try to do dividing by that whole thing. Just first term by first term. Okay, and we're going to end up getting x squared. We're going to put that up top, line it up, right? All your x squared should be in the same column. Then I multiply. So I'm going to multiply what we just got by the whole entire divisor. So I'm going to have x squared times x squared minus x plus 1. So I get x to the fourth minus x cubed plus x squared. So I have x to the fourth minus x cubed. See now why it's good that we had that x cubed column. And then plus x squared. Alrighty. When I draw the line, what do I have to do? Change all the signs, right? It's divide, multiply, and subtract. When I subtract and I distribute that negative sign through to all of these terms, the sign is going to change. So this is going to become plus, this is going to become minus, this is going to become plus, this is going to become minus. Okay, so we have x to the fourth minus x to the fourth. That goes away. 0x cubed plus 1x cubed is going to be x cubed. 2x squared minus x squared is just plus x squared. Then I have divide, multiply, and subtract. Bring it on down. So I'm going to bring this down. So I'm going to bring this on down, and then I'm going to bring it back to the division step, right? I've already done these first 4 steps, divide, multiply, and subtract, bring on down, and then now we have to start over again. So we're back to division. Don't be a hero, just divide the first underneath here by the first outside. So I'm going to have x cubed divided by x squared. Subtract those exponents so we get x to the first, or just x. All right, that's what I'm going to put up top here. Notice I'm lining my x's up. Then I multiply. I multiply x by this entire thing out front. So I'm going to multiply x by the x squared minus x plus 1. So I get x cubed minus x squared plus x when I distribute this through. Okay, so I get x cubed minus x squared plus x. Okay, divide, multiply, and subtract. Right, I'm subtracting now when I draw the line. And I'm subtracting that whole quantity. What do? Change all of the signs. Okay, so I'm going to now have x cubed plus negative x cubed. That's 0. X squared plus x squared is going to be 2x squared. Negative x minus x. Be careful here. This is going to be minus 2x. Okay, let's continue. Divide, multiply, and subtract. I have to bring on down now, right? Step 4 is to bring on down. So I'm going to bring down this plus 5. I'll do it in green. Okay, so then I have plus 5. And then I bring it back to the division step. So now again, I'm doing first under by first outside. So I have 2x squared divided by x squared. The x squareds cancel out to give you 1. And so I have 2 times 1, which is just 2. I'm going to line the 2 up with the constants up here. So that's my divide. What comes after divide? Multiply is next. Okay, so I'm going to multiply that 2 by the entire thing out front. So I'm going to have 2 times x squared minus x plus 1. Zoom out just a little bit. So I end up getting 2x squared minus 2x plus 2 when I distribute this through. 2x squared minus 2x plus 2. Okay. When I draw the line, I have to change all the signs, right? Because when I distribute that negative sign through, this is going to be positive, minus, positive, negative. Okay, so we have 2x squared minus 2x squared. That goes away. Negative 2x plus 2x. That actually goes away too. So we have 5 minus 2, which is going to give me 3. Right? Divide, multiply, and subtract. Bring it on down. Is there anything left to bring down? Nope. So can I bring it on back? Nope. Also, remember we would do first inner by first outside, right? 3 divided by x squared. See how that does not reduce to something that's not a fraction? Okay. We were going to get a fraction. 3 over x squared is a fraction. So because the degree of the remainder is lower than the degree of the divisor, we just stop there. Okay, so what is this? 3. 3 is going to be the remainder. Right? And remember, to write my answer, I always write my answer as quotient plus remainder over divisor. So my quotient was this, the x squared plus x plus 2. X squared plus x plus 2. Plus, what was my remainder? My remainder was 3. Over the divisor, what was my divisor? X squared minus x plus 1. Okay, and there we go. That's my answer for that first problem. X squared plus x plus 2 plus 3 over the quantity x squared minus x plus 1. Now we're going to get down to synthetic division. It says there is a shortcut. Yay! For dividing polynomials when the divisor is in the form x minus k or x plus k. The shortcut is called synthetic division. To use synthetic division, the divisor must be linear. Okay, the divisor must be linear to use synthetic division. Synthetic division is the easiest to use when the leading coefficient of the divisor is 1. Okay, so let's look at some possible divisors. Remember, divisors is just what you're dividing by. So if I look right here, you'll notice that the coefficient should be 1, right? And the exponent should be 1 in order to use synthetic division. So let's think of some examples where you could use synthetic division, like if my divisor was x plus 2, or if I was dividing by x minus 3, or if I was dividing by x plus 1, all of those work. Okay, and it's because they're all linear expressions where the exponent is 1, and they all have a leading coefficient of 1. See how the leading coefficients are all 1? So those would be good candidates of divisors that would work with synthetic division. Okay, like this one, 3x plus 2, you're going to see I have an x through it. It says you could use synthetic division when the leading coefficient is not 1, but it's tricky. You'd have to rewrite the problem. This is an honors level concept, so even though the expression is linear, I still am not going to use synthetic division in a CP Algebra 2 class, just because it's pretty difficult. You'd have to rewrite the whole problem in order to use synthetic division. Also, something like this, doesn't matter whether you're in a CP level class or an honors level class, you cannot use synthetic division on this one. You would have to use long division, and it's because it is not a linear expression. This is a quadratic expression. Okay, so if I said that I was going to divide by x squared minus 3, that's not going to work. If I wanted to divide by x cubed plus 1, that's not linear, so it's not going to work. Okay, you want that exponent to be a 1. Remember, if any terms are missing, you have to use 0 placeholders. Just like long division, for synthetic division, we may need placeholders. So here are the steps. They're not going to make a whole lot of sense right now, but once we do a couple note problems, I think it'll make more sense. For synthetic division, we're going to set the divisor equal to 0 and solve. That number is going to go on the outside. Then we're going to write the coefficients of the dividend inside across the top, putting zeros for placeholders. Bring down the first number, multiply, and then add, and then keep repeating the process of multiplying diagonally and adding vertically. Okay, so like I said, this isn't going to make a whole lot of sense till we do an example. If we look over here, see how my divisor is x plus 2? It is linear, and it has got a leading coefficient of 1. So I would set my divisor equal to 0 and solve. We get x equals negative 2. That's how I know what to put up here outside. Okay, so that's what we did, set the divisor equal to 0. That's the number that goes outside. Okay, then how do I get these numbers? The 2, the 0, the negative 7, the negative 11, and negative 20. How do you think that I get those numbers? From right here. The 2, we had to put a 0 placeholder because there was no x cubed term. Negative 7, negative 11, and negative 20. Okay, they're just the coefficients of your polynomial. So it says write the coefficients of the dividend inside across the top, putting zeros for placeholders. Okay, then we had to bring down the first number, right? Bring down the first number. You can see that the first number was 2, and I just brought it down. Then what are we going to do? We're going to multiply the divisor outside by the drop number. So I would do 2 times negative 2, and look, I get negative 4. I put that negative 4 in the next column under the next coefficient, and then we added the column down. So if I add down, then I would get negative 4. Okay, and we're going to repeat this process. We do this time negative 4 times negative 2, and I get 8. Add down. Then I take the 1 times negative 2, and I get negative 2. Add down. Then I take the negative 13 times negative 2, I get 26. Add down. Okay, so it's just, you keep doing that process of multiply, add, multiply, add. Okay, it says the bottom row gives the coefficients for the quotient. The last number is the remainder. Okay, the exponent of the answer should always start 1 less than the dividend's original exponent. Okay, and this should feel no different when I say that you want to write your answers as quotient plus remainder over divisor. That's what we've been doing for long division as well. Okay, so in this first example, I'm dividing by x minus 3. So I'm going to set x minus 3 equal to 0 and solve. Okay, so if my factor is x minus 3, then what's my solution? My solution is 3, right? If the factor is x minus 3, then my solution is x equals 3. Okay, see how it's almost opposite? That's just weird. Okay, but that's going to be the number that goes outside. Okay, then I list my coefficients up top. So this starts with a negative 1, x cubed. Then we have a 4, x squared. Ooh, see how we don't have an x term? I'm going to need to use 0 as a placeholder. And then my constant's 9. Okay, just watch this first. I don't want you writing it down yet. I want you to just watch the process, and then I'll do it again and you can write it down. Okay, so we bring the first down. Then we start our process of multiply, add, multiply, add. Okay, so I'm going to say we bring the first down, we BFD, and then we multiply, add, etc. until we can't anymore. Okay, BFD, mama, 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 mama. Okay, so I'm going to multiply -1 times 3. It's going to give me -3. Then I add down. 4 plus a -3 is 1. Then I multiply again. 1 times 3 is 3, and I put that in the next column. Then I add down 3. Then I multiply again. 3 times 3 is 9. Put it in the next column. Then I add down 18. Okay, this is your remainder. The last number is always your remainder. And then I'm going to work my way from right to left. If this is my remainder, then this is my constant, this is my x term, and this is my x squared term. So I'd have -1x squared plus 1x plus 3, which is my constant, plus the remainder over the divisor. And we were dividing by x minus 3. Okay, that's how that works. Notice that my answer, the degree of my answer is always 1 less than the starting degree. So my dividend was originally an x cubed expression, and my answer is an x squared expression. That's always going to be the case, where with synthetic division, it will be 1 less. Okay, so I'm going to erase all of this, and this time I want you to write it down. All right. So we're going to have, first, we set our divisor equal to 0 and solve. So our solution was x equals 3. So our solution is what goes on the outside. Then I write my coefficients across the top. We had -1x cubed. We had 4x squared. We did not have an x term, so I had to put a 0 placeholder in there. And 9. Right, we bring the first down. And then we start the process of multiply, add, multiply, add. So I multiply -1 times 3, I get -3. Add down, we get 1. Multiply 1 times 3, we get 3. Add down, we get 3. Multiply 3 times 3, we get 9. Add down, we get 18. Okay, the last number is my remainder. This is my constant. This is my x term, and this is my x squared term. If I had more, I would keep going. I would do, right, x cubed, x to the 4th, etc. But we don't. We run out of those coefficients. And we know that our answer should always be 1 degree less than what we started with. So I have -1x squared plus 1x plus 3 plus the remainder, which is 18, over the divisor. And the divisor, what I divided by, was x minus 3. Okay. Now, just a quick note, some teachers might show synthetic division a little bit different. Let me show you what I mean. I was going to see if I could just move this over a little bit. Here, I'll do that. Okay. Some teachers might present synthetic division looking like this, where they put a 3 in the box. And it might look like this, right? Multiply, add, multiply, add, multiply, add. Okay, it looks a little bit different just because the 3's in this box off to the side, but it's the same process. Okay, so don't be thrown off if your teacher next year makes their synthetic division look a little bit different. That's okay. All right, example 2, we're dividing by x plus 1. So my first step is going to take that x plus 1 and set it equal to 0. Okay, if x plus 1 is the factor, then what's the solution look like? Well, the solution, I would just solve for x, so I get that -1 is the solution. Okay, so that's going to be what goes outside my bar here. Okay, so I have -1. I write the coefficients up top. We have 3x cubed minus 2x squared, 2x, and a -5. So I didn't need any placeholders. Then I'm going to do my process where I bring the first down, and then I just keep multiplying, adding, multiplying, adding, multiplying, adding until I can't anymore. So I bring the first down. I multiply And then I'm going to add down. So that's going to give me -5. Then I multiply, and I would get +5. I put in the next column, add down. So I get 7. Then I multiply again. 7 times -1 is -7. And then I add down. So if I add those numbers together, we get 7, 8, 9, 10, 11, 12, -12. Okay? Remember, this is going to be my remainder. Then I have my constant, then x squared. If I had more, I'd keep going. X cubed, x to the 4th. Okay, but I don't have more, so I'm going to stop at x squared. I get 3x squared minus 5x plus 7 plus my remainder, which is -12, over my divisor. Don't put -1. Your divisor, we want the factor. That was your divisor. Okay, and that's going to be my answer there. Please notice that your answer, the degree of your answer is 1 less than the degree that you started with for your dividend, right? When we took 3x cubed minus 2x squared plus 2x minus 5 and we divided it by x plus 1, the degree is 1 less. Okay, and that kind of makes sense. Just like off to the side, if I write it like this, 3x cubed minus 2x squared plus 2x minus 5 divided by x plus 1. You can see if I'm dividing an x cubed by an x to the 1st, why there would be an x squared left. Okay. So now we get to the remainder theorem. So for the remainder theorem, it says if a polynomial f of x is divided by x minus k, then the remainder is equal to f of k. Well, what the heck does that mean? Like if my function is being divided by x minus 2, what is the solution that corresponds with x minus 2? Like if x minus 2 is the factor, then what's the solution? The solution would be x equals 2. So all this is saying is that the remainder, you can easily find it by plugging in whatever your x value is. In this case, it would be 2 into your function. So anytime I want to find the remainder quickly, I just plug in that k value. Okay, it says, long story short, the remainder theorem is another way to evaluate a function for a given value. Simply plug the solution k into your function and simplify to quickly find the remainder. Okay. It says we have already practiced evaluating functions in Unit 4, Section 1. Remember, if the factor is x minus k, then the solution is x equals k. Remember, if the remainder equals 0, then x minus k is a factor of the polynomial, and x equals k is a solution of the polynomial. Okay, so we're looking for a remainder of what for it to be a factor? We want the remainder to equal what? If the remainder equals 0, then it's a factor, okay? Or then x equals k is a solution. Okay, so pay close attention to what the remainder is. In example 3, it says evaluate the following when x equals -4. Okay, there's really 2 ways that we can evaluate this. Okay, we can either just simply plug in -4 for x. That would be really an easy way to evaluate. The other way that we can evaluate an expression is with synthetic division. So, or we could use synthetic division. And put the remainder as our answer. Okay, so we have 2 ways to evaluate an expression now. In part A, I'm just going to practice plugging in -4 because for part B, it tells us to use synthetic division. So let's go ahead and just practice the first method. So I'm going to do f of -4. So I'd have 5 times -4 cubed minus -4 squared plus 13 times negative 4 plus 29. Okay, remember we want to take care of those exponents first. So I'm going to do the negative 4 cubed and the negative 4 squared before touching anything else. We'll get that f of negative 4 is equal to 5 times, let's see, negative 4 times negative 4 is a positive 16. And then if I multiply positive 16 by a negative 4, I would get negative 64 minus negative 4 squared is going to be 16. And then we have 13 times negative 4, which is negative 52, plus 29. Okay, so now I'm going to go ahead and just multiply the negative 64 by 5 and plug the rest of this into my calculator. And we get that f of negative 4 is negative 359. Okay, now remember, on a graph what this would look like when x is negative 4, the y value is going to be way down here at negative 4, negative 359. It's going to be a really, really, really low point. So just keep in mind that that's really an ordered pair. So what the remainder is finding is the difference from the x-axis, right? Or the distance from the x-axis. Really, it's going down 359 from the x-axis. So now when we use synthetic division to evaluate this, we'll put the negative 4 outside. We'll list our coefficients, 5x cubed minus 1x squared, 13x, and 29. We bring the first down, multiply, 5 times negative 4, that's going to be negative 20, add down, multiply, negative 21 times negative 4 is going to end up being, let's see, that's going to end up being 84. And then we add down, so 4, 5, 6, 7, 8, 9, so we get 97. Then we multiply 97 times negative 4. And that's going to give me negative 388. Okay, which if I add down then, I get negative 359. And remember the last number here is my remainder. Right? If the remainder was 0, then there would be no distance from the x-axis, and it would be right on the x-axis. Okay, but since it's negative 359, you know you're going down 359 from the x-axis. Okay, I like when the remainder is 0 because then I have an x-intercept. Okay, so I'm just going to put a nice sentence at the end here that says, by the remainder theorem. And I'm going to abbreviate theorem. The remainder is equal to f of negative 4. So f of negative 4 must be equivalent to negative 359. Okay, here for the next part C, it says, what does it mean if the remainder is 0? Remember, let's go back up here. It said it right here in this sentence. If the remainder equals 0, then x minus k is a factor and x equals k is a solution. So if the remainder equals 0, then that would mean that x minus k is a factor, or x equals k is a solution, or x-intercept. Remember, solution and x-intercept we can use interchangeably. So because this remainder was not 0, then our divisor would not be a factor. When the remainder doesn't equal 0, then x plus 4 is not a factor. And x equals negative 4 is not a solution. What does the remainder have to equal in order for it to be a factor or a solution? It's got to be 0. Okay, in this case, it was not 0. So, all right, let's try this one. We're going to divide this expression by x minus 2. It is linear, right? Leading coefficient 1. So it is a good candidate for synthetic division. We're going to set this equal to 0 and solve. We put the solution on the outside, list the coefficients, 5x to the 4th, 2x cubed. We do not have x squared, so I'm going to have to put 0 for x squared, negative 20 for x, and negative 6. Bring the first down, multiply, add, multiply 12 times 2, we get 24, add, multiply 24 times 2, we get 48, add, and then 28 times 2, what would that be? 28 times 2 would end up giving me 56. And then I add down and I get 50. Okay. So is x minus 2 a factor? I can already see that no, it's not a factor. How do I know it's not a factor? It's not a factor because the remainder is not 0, right? In order for it to be a factor, the remainder has to be 0. Okay, so I end up with, this is my remainder, right? So if I'm thinking about this, we're going to have a distance of 50 from my graph, right? Like I'd have 2 comma 50. So if I'm plotting this, it's going to be 50 up from my x-axis, right? If I got a remainder of 0, it would be on my x-axis, but 50 means it's up from it. And then this is going to be my constant, my x squared, and my x cubed terms. Notice that my degree is 1 less than what I started with, which is good. So I'm going to write 5x cubed plus 12x squared plus 24x plus 28 plus 50 over, and what was my divisor? My divisor, or what I was dividing by, was x minus 2. Okay, that's what I get from the division process. And then it says in the next part, it says, use your results in part A to evaluate f of x when x equals 2. So when you see this word evaluate, you can either use, right, where you plug it into the function. So in this case, I could find f of 2, where I just plug 2 into my original function up here. Or another way that you can evaluate, or the other way you can evaluate, is to do synthetic division and look at the remainder. Okay, so in this case, since I've already done the synthetic division when x, or my solution, was equal to 2, right? I've already done the synthetic division when x was equal to 2. I can just look at my remainder, right? By the remainder theorem, my remainder should be equal to f of 2. Okay, so because my remainder up here was 50, f of 2 should also equal 50. And there are some questions you'll have to answer like this, where you're going to have to explain that you're using the remainder theorem. Okay, and if we want to check our work, like let's just check our work really quick. Let's just go ahead and plug in 2 into our function. So if I'm doing f of 2, and I'm using this function up here, we would have 5 times 2 to the 4th plus 2 times 2 cubed minus 20 times 2 minus 6. And I'm just going to plug this all into my calculator. Let me get my calculator. I hear some ruffling papers. Okay, I get 5 times 2 to the 4th. Actually, put this in your calculator. Plus 2 times 2 cubed minus 20 times 2 minus 6. And I get 50. Okay, so that does in fact work.